So here in Chapter 8, we're going to start making a different type of inference based on a single sample. So in the last chapter, we found point estimates and interval estimates of population parameters. Going forward here, we're going to use inferential statistics to test hypotheses here. So for example, does a new drug work better than placebo? Will the sitting governor win election, or will the challenger? Are the lead levels in Chicago public schools below the action level? And as we answer these questions, how reliable are our conclusions? So let's look at this last question here. Let's say that the action level for lead in drinking water is 15 parts per billion. Samples were taken from drinking fountains at 30 randomly selected public schools in CPS. The sample mean here, sample mean level, for the 30 schools was 16.2 parts per billion. The standard deviation was 2.4. So we've got mean and spread. Is this enough evidence to conclude the mean for all of the schools in the district is over that action level at the 0.05 significance level? So that's the question that we want to answer. In order to do that, we need to carry out a hypothesis test. So let's first talk about the elements of a hypothesis test. So a statistical hypothesis is just some statement here about the numerical value of a population parameter, like the population mean or proportion. And we want to make a decision between two opposing hypotheses that are negations of each other. If we show that one is not probable, then the other one will be true, probably true, at least with a certain degree of reliability. So the first of these two opposing hypotheses is called the null hypothesis, denoted H0. This is the status quo hypothesis, the nothing happens, no difference hypothesis, usually stated as parameter equals some default value. This hypothesis is accepted unless the sample data provide convincing evidence to reject it. So if our sample data is extreme and it indicates that our null hypothesis is not true, then we conclude that the alternative or research hypothesis is true. So this is denoted H sub A, and this is what we want to show. So this is usually stated as the parameter is greater than, less than, or not equal to a value. And the sample data if the sample data provide convincing evidence, so if that sample is too extreme to be due to chance, we reject the null hypothesis and accept the alternative. So that's the way hypothesis testing works. So how do we decide what evidence is convincing? Well, we have to look at what's called a test statistic. So a test statistic is a sample statistic that you compute from the sample data. It's actually a z-score of the sample data. And then the researcher uses this to decide between the null and alternative. So if this value of the test statistic is extreme enough that it's not likely due to sample variability or chance, then we'll reject H0, reject the null hypothesis. Well, let's first just formulate some null and alternative hypotheses here. So in this first example, a pharmaceutical company is testing a new diabetes drug. Persons considered diabetic if their hemoglobin A1C blood level is 6.5 or higher. The company wants to establish that the drug works. So they want to establish that the drug works for diabetics. So if it works, that means that it's going to lower this blood level. So start with our HA, what we're trying to show. We will try to show that the mean blood level for the population that gets this drug, mu, is less than 6.5. If that's not the case, then we'll accept the default value mu equals 6.5. Now sometimes you'll see this written as mu greater than equal 6.5. So the null hypothesis will be greater than equal, less than equal, or equal. So those are equally acceptable to me. The state is testing a new program to discourage texting while driving. So before the program started, 24% here of Illinois drivers admitted texting while driving. So that's sort of the default known value. The governor believes here that the program has decreased the percentage of drivers who text. And so HA, what we're trying to show is that that percentage or proportion has decreased. So P less than 0.24. If that's not the case, then we'll accept the default previously known that P equals 0.24. Although you could also do P greater than equal 0.24. Depends on the textbook that you look at, whether it's equal or greater than equal, less than equal. So both of these were what we call one-sided tests, less than or greater than. We're trying to show directional. If it says instead of decrease, if it just said changed, then we would have equal, not equal. So that's null and alternative hypothesis.